Hi everyone. Congratulations, you made it to the end. I promise I will go easy on you and there will not be a lot of technical details in my presentation. I bet that there are at least some of you here that have happened to work or seen a scattered code base, and by that I mean one that is living in separate repositories and maybe even lost track of dependencies because of that scattered code base. Which might have led you to question how is this setup working for you and do you need to change it? In the JavaScript world, it's very likely that you have at some point come across these concepts or those issues, and even though we are at Angular Day and my use case is involving an Angular product, some of the concepts I will be talking about are valid for other, let's say, JS flavors as well. And specifically, we are going to be discussing advantages and disadvantages of multi-repository versus monorepository setup. For some of you who might not be familiar with those setups, multi-repository, or multi-repo for short, means that each of the project is living in its own repository, and they are dependent between each other. While monorepository, on the other hand, means that all of the projects share one code base. Throughout the years, I have had the opportunity to work in different teams, know different strategies for managing repositories and kind of projects. I have been in projects with different complexities, but most importantly, my path led me to my current workplace, which is Progress, and I got to ask myself the big question: to monorepo or not to monorepo? And the use case I'm going to present to you today involves a product called CanDoUI for Angular. Some of you may have heard of it, others maybe even used it, and some of you may be asking yourself, well, isn't Kendo a Japanese martial art? Well, yeah, it is, which is why our mascot is called the Kendoka. But also, apart from this, CanDoUI is a web components library. It is a set of reusable UI components, which consists of some big ones, for example, data grid, charts, and editor. But it is also very important to mention that it consists also of small components like buttons and inputs. And all of these smaller components are actually being reused in the big ones, which is creating that sort of interdependencies between the different libraries. Let me give you a bit of a backstory. For CanDoUI for Angular has been around since 2016. Nowadays it has more than 120 components, and those components, prior to the migration, used to live in about 50 separate repositories. The team currently consists of 13 members, and we also have a couple of friendly neighborhood guys that are pitching in, and they did just that while helping us set up our monorepository. So back in 2016, I wasn't part of the team. That's why I went and asked some of the people that were, and I asked them, well, why did you decide to go with the multi-repository setup back then? And some of the key points that I extracted were that what was important for the product and the team was that it had modularity and separation of concerns, meaning that they wanted each package or the different set of components to have their own repositories, and that would have allowed for more clear semantic versioning and independent releases, which means that if there is a bug fix, for example, in the buttons package, only that library needs to be published, only its version will be bumped, and the rest will just remain the same. And at that point, that meant that the builds would be simple, there would be no unnecessary test rounds, for example, which would mean less time spent waiting for builds. But since 2016, things changed drastically, because in 2016 the library had 19 components. It wasn't that big of a deal, but over the years those components, the number of those components grew, respectively the repositories grew, and the intricacies and interdependencies between them grew as well. And then dependency management really hit us in the face. It is really hard to make sure that there were no version conflicts, because the different libraries may at some point end up with different peer dependencies versions, which would result in a problem for our clients if they decide to use both libraries at the same time. Inconsistencies as well, because if there was a major update in one of the components, which was really nice, but we forgot about it and we forgot to go and bump that version in one of the other packages, then we were missing out on things, really. And all of this complexity practically meant that we were losing track and visibility of what was really going on with our dependencies. And to illustrate how complex things got, here is the real dependency graph of our project. I mean, you cannot even see it, let alone be able to track what is going on, and if something changes somewhere, to go and update the rest of the repositories. Another problem that we hit was the number of repositories. As I mentioned earlier, they grew to about 50 repositories, and that meant we were dealing with great overhead, meaning more setup, more maintenance, tracking of issues was dispersed throughout them, pull requests all over. If change was needed, if there was a common change, it meant that each one of the repositories needed to be updated. Let me give you a specific example to show you what I mean. At some point, we needed to update our documentation to include some steps about standalone components, and you see that here was one of the change, and we added a section how to actually use them in standalone components. Well, this seems pretty simple, and it is just a documentation change, really, but for us that meant 50 or more pull requests, because we had 50 repositories, and each one of it had its own, because each one of the components has a separate section for how to be used in modules or standalone components. And that resulted in 150 builds because one build was run for each of the important branches. And have in mind that this is the documentation change. It's not in the source code, and you don't actually need to, you don't have to build the packages all over again. You don't have to run the tests because it just happens so that the documentation lives in that repository. It's not part of the library that is being shipped. All of that also brought a lot of complexity and problems for our quality engineers and the way they had to reinvent testing, because when making a change in just one of the components, for example the inputs, it wasn't enough to run the tests there or go and manually check if this is working as expected, but you also have to go through each of the other components that have it as a dependency and make sure that their tests pass as well and everything is okay. By the end, the entire deployment process has turned out to be a very carefully orchestrated chaos. We had to be careful for the exact order sometimes in which we needed to release our libraries, which was really starting to take a toll on us. Yeah, back in the beginning, have in mind that those problems, they didn't occur all at once. They weren't that serious at the beginning when we started to seeing them. But as time was passing, more problems presented themselves. They were becoming more serious. The team even started discussing, okay, maybe Monorepository will help us. But as they were not that serious, we also told ourselves, it is not the time right now. We don't have the capacity and the resources, and the benefits will probably not be that good. But after some more time, it got really worse. Some of the team members were really starting to get pissed off because they had to go and do one thing in 50 different places. And this is when we told ourselves, okay, well, it's high time we do this. So let's see where we should start. And the first thing that someone should look at is the project itself. What are the needs of the project? What is the timeline you are looking at? What is the capacity, for example, that you have? And then you can move on to evaluating your tools. We decided to look at those three options. Can you make a guess which one we chose? Okay, it wasn't Turborepo because in combination with Angular, it happened to fail at parallel processing, which was really important. It wasn't also Verona. At the time we were evaluating it, it was at version 6, and the company that is behind NX had already acquired Lerna, so we also took that into consideration, and we told ourselves they might not continue its development, or they are going to push it in a way that is going to be similar to NX. So NX was our winner. Imagine if it wasn't, it would be really awkward right now. So, in combination of NX and semantic release, we started constructing our monorepository. I'm not going to be talking in details about NX as a build tool because thankfully you already did that. But first, before continuing with some specific statistics, how NX fit our use case, and build further upon the previous lecture that you saw with some specific use case. Just a quick side about the dependencies. So we weren't relying on different versions anymore. The entire library, all of the packages in it, started coming out in one version, and it was really easy for dependency management tracking because semantic release plugin took care of that, and in the code there was just placeholders. We didn't have to go and manually bump the version each time we release, which was kind of awesome. So after we have established where to start, the next thing to do is the migration process itself. After the tool was chosen and the project is assessed, I would highly recommend that if you happen to do that, to adopt a phased approach, because that will allow you to really refine the process. And by that I mean, first take one of the projects and migrate it, see how it behaves, how it works, then take the next one, see how it interacts with the other one. Don't try and do everything all at once. And have in mind that there will be a learning curve for the team as well. They will need some time to adjust to the new setup, to the processes, but eventually they will adapt. So it took us about 3 months for the entire thing, the planning, the research, the execution. We had about 7 fully dedicated developers at some point. I mean, initially there were 2 people that really made the research and proof of concept, and then it was needed for maybe a couple of weeks or 3 for 7 full developers to go in and finish out the migration based on the refined process. This is where it's really important again that the process is refined, because after that was done, it was really easy for that 7 developers to go in and follow specific steps and know what they have to do. I haven't calculated how many dev hours, but in my mind it was a lot. But finally, we had our much wanted monorepository. We were happy to have a really simplified dependency management, which made it easier to ensure the version compatibility. The development environment was in one place, and if something was it was consistent, it was much easier to ensure that there are no differences. My personal favorite is refactoring code. Remember those 50 pull requests from earlier? Well, that kind of change now can be done with just 1 pull request in the monorepository instead of 50. Visibility and transparency in our case, because Progress is a big company that is developing not only Can-Do, and other teams are using internally Can-Do, and it was sometimes hard for them to get around, wait, I'm looking for something specific, but in which repository does it live in? Now when they need something from Can-Do Angular, they know where to look because we have just one repository. And one other benefit was increased collaboration within the Angular team itself, because previously, not intentionally, with so many repositories, some people were used to working on some components while others were used to working in other parts. But having the code base in one place really pushed the team into communicating more and collaborating on common tasks. However, As much as I am a believer and I want everything to be sugar spice and everything nice, with having the entire code base moved into a monorepo, an entire set of different kind of problems started to emerge. The first one is the complexity of the build setup. This is something that we hit during the migration process itself. It wasn't after we were completed the migration. As the code base grew and all of those projects came together in one place, the build times started increasing significantly for us, and the testing duration, the time it took for end-to-end visual and unit tests to run, was also huge. So to deal with that, potentially the monorepository needs to figure out, okay, let me see what was changed, and do I need to run all of the tests? Do I need to build all of the projects all over again? I don't want to do that because that would be insane, right? And here is again where NX came to the rescue for us. Thanks to the caching mechanism and the affected command, we were able to deal with the build times in a very positive way. Let's talk some numbers. This is the accurate number of tests that the library had about a month and a half ago, probably more nowadays. And if we look at a relatively medium package, let's say the drop-downs, it's not the biggest one, but it's not the smallest one, because the drop-downs are used in a lot of the bigger components. If we make a change in the source code there, and let's say that there are no optimizations, no affected command, no caching mechanism, that would mean that we would need about an hour and a half to wait for the packages to build and for the tests to run. We don't have an hour and a half. That's pretty much. Then enabling the caching in the affected command of NX reduced the number of tests and the packages that needed to be rebuilt to only those that were actually affected as consequence from our change there. And that reduced the time to 50 minutes or an hour, which was honestly still a lot. The next step that we took was parallel processing, and for this we separated the build into 4 different machines, having the packages built separately, end-to-end tests also, and the ahead of time compilation tests. One thing that they had all in common, but it was really needed to allow them to start building in parallel, was just the container setup in the npm install. Otherwise, end-to-end tests didn't have to wait for the packages to be built because they had their own example projects and they didn't actually need the actual builds. And that, as you see, reduced the time to under 20 minutes, but this was actually thankful also to the parallel processing that NX is also offering, because apart from us dividing the build into 4 separate machines, also the processes there were parallelized as well. And about 19 or 18 minutes for that kind of package compared to the hour and a half previously was something that we can live with. Having figured that out, we came across collaboration conflicts. And yes, I mentioned earlier that collaboration was improved. However, it is a two-way street, and as much as it did get improved, it also started hindering our day-to-day work. You see, now you have about 10 or so developers that are contributing in the same code base, and that means that all of the pull requests are made in one place, and this makes it prone for a lot of merge conflicts, and people had to either communicate really well between each other, or for example have one of the developers be responsible for organizing how things should be merged, how branch should be updated, and so on. Luckily at that time also GitHub had released their merge queue option, which is really good. If you haven't used it, I really urge you to try it out. It when you have a pull request, you just click add to merge queue, and then the merge queue is taking care to merge it to update to the current, for example, development branch. And if the tests fail, for example, or if it is not able to merge it itself, then one of the developers needs to go in and do something. Otherwise, it works pretty well. And something new that they are working on is, and still in beta, is the code freeze option. It's something I'm looking forward to use, because I don't know if you do, but we do have code freezes, and there is always some developer that that didn't know that we were in a code freeze and goes ahead and merge something, for example. But with the GitHub merge queue and the code freeze option, that will not be possible anymore. Have in mind that this is a specific case for a small team, because having 10 or so people contributing is not that much compared to some of the bigger companies, for example, that work in a Monorepo setup. And if there were twice as many or even more people doing so, probably that's what I just said would not be enough, and the strategy would need to be revised further. One other thing that I wouldn't say is really a disadvantage, but it is something that you should be aware of. With one code base and the unified dependency and version, that meant that all of the packages now had a single version number. And why that might not be the case, why that might not be the best scenario. Well, if, for example, we take one of the components, we are making some sort of breaking change to it because it is needed, and the version needs to be bumped with one number. Well, for us, that also meant that all of the other packages received that new version as well, regardless of whether they have even received a single fix. That might be falling a little out of the semantic release ideology, but actually we again decided to look at the bright side of it, because based on the feedback from our clients specifically in the past, having that explicit semantic versioning previously with all the different numbers for the different packages in the library wasn't really working out for them as well. So one good thing that came out of the single version is we now had a unified changelog. Previously, it wasn't possible for us to have a common changelog because all of the packages had different versions, and sometimes in release cycle some of the packages didn't get a feature, didn't get a fix, and they weren't released at all. But now we have a unified changelog, and if you want to see what's in v13, you can go and see it for each one of the packages. One version also would allow us to have documentation versioning, and I'm saying would because it is something that our clients have been requesting a lot, but we haven't done it yet. It's in our future plans, and it's now possible, and it weren't before, so that's great. And consistent versions are really also beneficial for the people that are using those libraries because they don't have to really think, wait, I am using 10 of your packages, well, what are the new version numbers so that I can update them, for example, but they can just see the new version number is 13, so I will go ahead and update all of my packages to that number. For us, Monorepo really works. I think it's great. But before you jump in and agree with me or start migrating to Monorepo as well, think about whether the project would fit the case, because for Web Components library, to be living in a Monorepo, I think it's the perfect case. But that might not be true for every project. For example, if the projects are not really that dependent on each other, then you might be just fine working in a multi-repository setup. Before you go, I want to kind of summarize and leave you with a few takeaways from today. First, the most important thing before you decide to do anything is understand your project, its needs, also the team needs, and also make sure that you know your tools. They do matter. They are also changing, because if we were to do the evaluation today, I bet that some of the tooling might be different, and who knows, we might end up in a different to a different conclusion. One other thing that is really important is really having your processes governed so that you can kind of control the chaos, and the people on your team can know what this is about and how they should do it. And for me, one of the most important things generally in development is that you should know that things are changing constantly. And we should change and evolve right with them. There isn't always one solution that fits all problems, that provides the solution to everything. But we need to be curious. We need to be bold. We also need to challenge the existing. We need to ask questions, and we have to know that maybe some solutions are not perfect, but they might be better than what we are doing nowadays. And yeah, we did that migration about a year ago or so already, but that doesn't mean we are done. We are continuing to face new problems. We are gonna tackle them, and who knows, maybe next year I will be here again telling you about another migration we did. So thank you all for your time. I'll be happy to connect with you.
Thank you. Thank you, Stefani. Any question now? No question. So when you say thank you, their mind switched completely. Now they are thinking about spritz. Yeah, spritz.
Yeah, I can feel them. I'm also thinking about going to the Christmas market, you know.
But now you have to answer some questions.
Do you use some tool to improve the process of searching and to analyzing code on your Monorepo?
When you mean analyzing in kind of what?
Both things. Tool for to search the code. You need something and you try to look to find on the repository. You need some particular classes, some function. And tools are two separate questions, in fact. Do you use tools to search the code and tools to analyze the code? For example, looking for anti-patterns and other things that you or other devs might accidentally have introduced, like SonarQube or tools like that?
The first part of your question about searching, I think that Visual Studio Code is doing a pretty good job for now, for me at least, because when I open the Mono repository there, the search, it's doing pretty great job looking for everywhere. GitHub also has that functionality as well already, I believe. As far as the tooling, we do have, for example, linting implemented. Scanning code for anti-patterns we don't, but we do have security scanning code, which is kind of really important when you do sell a product. So yeah, I think that's what's on top of my mind right now.
How did you parallelize your pipelines? You used NX Cloud, or you used something made at home?
We are using our own infrastructure for the parallelizing.
Other hands?
Kind of a triggering question. Like, nobody in your team did regret the switch to the Monorepo? I don't think so, but
no,
I was curious.
Not even one person.
I'm looking for other hands. Hop, 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 hop.
Do you have to maybe handle code ownership and permissions on your code base? Like, one team is responsible for a part of the library, and how do you handle who gets to edit the code? Because since it's all
the way we are set up, we have a GitHub organization which has a lot of private repositories inside with separate access management. Actually, earlier when we had the multi-repository setup, that was one of the advantages, that we had more granular access control. We had some external contributors, for example, contractors, that needed to contribute from time to time, and that was good because they had access only to that part of the code that they needed to do their job in. Right now, with the Mono repository, we also kind of have that granularity because the Angular team only has access to that repository, not the entire organization. But yeah, when you cannot have more granularity than that for the separate projects, let's say.
Other hands? Possibly on the completely opposite side of the room? No. No, okay. So thank you, Stefani. A big round of applause for Stefani. Thank you.